I want to welcome you to the video for Lecture 4, Unit 1. This is for Statistics 2023. My name is JOrge. And in this lecture, what we're going to be talking about is observational and experimental studies. So the first thing is, the objective for this particular lesson is simply to know the difference between what an observational study is and what an experimental study is. So here I have a couple of examples. And it says that 91% of Americans say they wash their hands after using a public toilet. However, an observational study conducted in 6 U.S. airports found that only 26% of men and 17% of women actually wash their hands after using a public toilet. And then a recent survey also found that only 24% of men and 39% of women always wash their hands after they cough or sneeze. So these are obviously, one is an observational study, and the other one, actually they're both observational studies because we just get data from the sample. So what's an observational study? So an observational study is just observations and measurements of individuals that are conducted in a way that doesn't change the response or doesn't change the variable being measured. And that's very important. So here's an example. We find 100 women, aged 30, of which 50 have been smoking a pack a day for 10 years, while the other 50 have been smoke-free for 10 years. Then we measure lung capacity for each of the 100 women, and then we analyze, interpret, and draw conclusions from the data. And that's an observational study because we didn't do anything. We found what was already there, and we just observed it and then measured it. Now, an experimental study, the researcher manipulates one of the variables and then tries to determine how the manipulation influences other variables. So here we have an example. So we're going to find 100 women aged 20 who do not currently smoke. And then we're going to randomly assign 50 of the women to the smoking treatment and the other 50 to the no smoking treatment. And then those in the smoking group will smoke a pack a day for 10 years, while those in the control group will remain smoke-free for 10 years. And then we're going to measure lung capacity for the 100 women. So obviously, this is an illegal study. You can't actually do this, but that's an experimental study. It's a trivial example of what an experimental study is. So here we have a couple of examples. We're going to determine are they observational or experimental. So the Colorado Division of Wildlife netted and released 774 fish at Quincy Reservoir. Now there were 219 perch, 315 bluegill, 83 pike, and 157 rainbow trout. And the second one is the Colorado Division of Wildlife caught 41 bighorn sheep on Mount Evans, gave each one an injection to prevent heartworm. A year later, 38 of these sheep did not have heartworm, while the other 3 did. So the first one is observational because nothing was changed. All the researchers did was just catch them, measure them, and then put them back. And then the second one is experimental, and the reason being is because they gave them the injection to prevent heartworm. So they actually did something that can ultimately change a variable. So here we have 2 of the examples. The Colorado Division of Wildlife imposed special fishing regulations on a Deca section of the South Platte River. So all trout under 15 inches must be released. Now, a study of trout before and after the regulation went into effect showed that the length increased by 4.2 inches after the new regulation. And then the other one is an ecology class used binoculars to watch 23 turtles at a pond, and it found that 18 were box turtles and 5 were snapping turtles. So the first one again is experimental, and the reason being is because they implemented a regulation that changed the type of fish that you can actually keep. And then the second one is observational. So how can we tell the difference between observational and experimental? The first one is the difference is in who decides on the treatment assignment. An experimental, the researcher decides between the treatment and control group. In an observational, the subjects simply assign themselves. So in an observational study, the researcher simply observes what happens. The other type of experiment is what is called a quasi-experimental study. And this is when researchers use intact groups, or let's say a classroom, because random assignment is not possible, especially if you're doing an educational study. Now, variables that get tested through, they are assigned randomly. So whatever we're actually testing, that's randomly assigned. And this type of study is often used in education, also in social sciences and psychology. So here's an example. What's the effect of technology in schools? So the first thing that happens is that a school is selected that does not have computers. And then you evaluate the students' performance in the school. And then now you provide the students in the same school access to computers, but at the same time, you allow the students to choose whether or not they're going to participate in computer classes. And then you evaluate the performance of students who use computers compared to those who don't. So let's talk about variables. In variables, we have independent variables and dependent variables. So in an experimental study, the independent variable is the one that's being manipulated by the researcher. And it's also called the explanatory variable. Now, the dependent variable is what we call the resultant variable or the outcome variable. And this is the one that's being studied to see if it has changed significantly due to the manipulation of the independent variable. So going back to the the computers example, if the students, what they were measuring was the outcome. So did they have learning gains or not if they used computers or if they didn't. Next thing we're going to talk about is a treatment group and control group. So a treatment group is the item of the subject that's being manipulated. And the control group is used as a baseline measure. So the control group is identical to all other items or subjects that are examining, with the exception that it does not receive the treatment or the experimental manipulation that the treatment group receives. So that's why you have a treatment group and a control group. So here's an example. Studying the effect of a new surgery. The treatment group, patients who get new surgery, and the control group are the patients who get standard surgery. Studying the effect of smoking. The treatment group will be the smokers and the control group will be the non-smokers. So I want to talk about the Hawthorne Effect. And this was in 1924 in a Hawthorne plant of the Western Electric Company. So it gets its name from the factory that's called Hawthorne Works, where they conducted some experiments on factory workers between 1924 and 1932. And what happens was that the effect was observed for minute increases in illumination. So what they did was they increased the light intensity, and then they measured to see if the workers became more productive the brighter the work area was. And then, so the stimulation, the output or accomplishment that resulted from the mere fact of being observed. So let me talk about that for a second. So what happened is that as they increased the light, they noticed that the workers actually worked harder, so they worked more. But eventually what they found out was that it wasn't because the light was getting better, it was because they actually were being watched. So the more they were watched, the more they worked, because obviously they didn't want to be watched and not doing any work. So it wasn't the light, it was actually the fact that they're being watched that increased productivity. And this is what's called a confounding variable. And this is a hidden variable in a research that affects what you're looking at. In this case, in the Hawthorne Works, we're looking at outcome, right? Productivity. So the hidden variable was that they're being watched as opposed to what they were trying to see if it had any effect, which was the lighting. And hidden variables actually and can potentially distort the resulting data. And this is also known as a hidden third variable that causes the two measured variables to falsely appear to be in a relationship. So what happened was in Hawthorne Works, there was a false relationship between the better lighting and productivity as opposed to simply being watched. And in such relation between two observed variables is what we call the spurious relationship. So here's an example. Ice cream consumption and murder rates are highly correlated. Right? So the question is, does ice cream incite murder, or does murder increase demand for ice cream? And so it sounds like it's trivial, and it sort of is, but if you simply look at the data and you see, okay, well, ice cream, as the consumption of ice cream increases, murder rate increases. So is there a relationship between the two? Actually, there isn't. The confounding variable here is weather. So as the temperature increases, ice cream consumption increases, and believe it or not, the murder rate increases. So another look at the samples showed that it failed to account for the time of the year, including the fact that both rates, ice cream consumption and murder rates, rise in the summertime. And this is the end of Lecture 4, Unit 1. Thank you.